Okay, so we're trying to solve this example 13.24. Okay, in a machine, the intermittent operation demands the torque to be applied as follows. So torque, which is a turning effect, okay, which is producing the power. Okay, if you remember, the formula for the power was torque multiplied by angular velocity. Okay, so this is producing the torque. So the intermittent operation required this type of torque. What is that type of torque? Is number one, during the first half revolution, the torque increases from 800 nanometer to 3000 nanometer uniformly, which means straight line. Okay, 3000 to 3000 to 800 to 3000. Uniformly means a straight line. If you recall it, we have done this thing in the CAM profile as well. When the uniform velocity, we draw the straight line, which means a straight line, no curve, nothing. During the next one revolution, the torque remains constant. So it reached the 8000 and then it remains the constant. During the 1.5 revolution, okay, there's some problem in the text. It's basically 1.5 revolution, okay, which means one full and one half. So each revolution is like 2 pi, okay. So one revolution is 2 pi, 1.5 revolution is 2 pi and pi, 3 pi, okay. We'll see that there is some the second one during the next one revolution. No, this one is right. During the next one revolution, so 3 plus 2 is 5. Okay, this one is also right. The torque decreases from 3000 to back to 800. And during the last half revolution, yeah, the problem is this statement. It's not half revolution, it is basically 1/2 revolution, which means 3 pi. One complete revolution, 2 pi, and one more half revolution, it is 3 pi. So 5 pi plus 3 pi is 8 pi. So at the end of the day, it's at the end of the graph, it's 8 pi. Sometimes you have this accompanied graph, and sometimes you do not have this accompanied graph. So you need to read the information and extract the input data and draw it by yourself. So it's a turning moment diagram. On x-axis we have angles, and on y-axis we have turning moment. Thus the cycle is complete in 4 revolution. Yes, 4 revolution means 8 pi, because each revolution is 2 pi, 1, 2, 3, and 4 revolution. The motor to which the machine is coupled exert a torque, constant torque at mean speed of 250 rpm, a flywheel of mass 1.1800 kilogram, and the radius gyration is given, which is 500 millimeter. We need to find out the power of the motor and the total fluctuation of the speed. So to find out the power of the motor, we need to find out the T mean. What is the T mean? Mean torque. The T mean is the torque which needs to overcome all the friction, inertial forces, any other forces, if it has to generate heat, if it had to lose some energy, because all the energy cannot be converted into useful work. So this is something. So what we need to do, we need to find out the total area under the curve. So this one is very simple, because at the end of the day, this diagram is nothing but the combination of rectangles and triangles. And to find out the area of rectangle triangle is very simple. And once we get the whole area, we divide it by the total revolution, and hopefully we get the TeV. Okay. Once we get this thing, and then the formulas which we used it earlier on, we'll use them to get the other second part, and the second part is total fluctuation. We'll get the fluctuation from there. All right, so let me draw this over here. Okay, we have 0, like 800. So from the 800, we go to something like this, just the pi, first half revolution, then we have a constant, then we go down, then we have this. This one is pi, 2 pi, sorry, 3 pi. This one is pi, and this value is, because it's given in the data, is 3000. So this axis, you remember all the graphs, they must have label, they must have units on each of the axis. So this one is basically turning moment, and the units are, what are the units? Newton meter. Or let's say we write the units here, Newton meter. And on this side we have Frank angle, and the units are radians. Okay. Just to identify these points, let's name it A, B, C, D, E, and F. Okay. So to find out the area under this curve, because it's a very simple straight lines, so what we can do is we can divide it into, yeah, very primitive shapes like rectangles and squares or triangle. Okay, so we made one thing. So we got this whole thing, let's call it, all right, don't call it, just we'll write it. One over here, one over here. All right, we can call it area 1, area 2, area 3, area 4. Agreed? So what we need to do, we need to find out the total area. Total area for this, we can say this equal to area OAEF, OAEF plus area. Okay, we need to name other parts as well. Let's say we call this as L and this one as M. So area ABL plus area, this rectangle, area BCLM plus area CMD. In other words, because we name the areas as 1, 2, 3, we can also call it A1 plus A2 plus A3 plus A4. Okay, very simple, very easy, nothing. So what is the area A1? 0 to 8, and this. So what we can say is it is equal to 800 multiplied by 8 pi. Am I right? What is the area 2 or ABL? This is a triangle and the area is half base AL into altitude. So what is base AL? Okay. Or do you want me to write in terms of variables as well? It's very simple. It's okay. And then we say this height B to L. What is this height? 3000 minus 800. Okay. Area 3. This one is rectangle. So we say 3 pi minus pi. So basically it's just 2 pi. And again this part, which is 300 or 3000 minus 800. Plus area 4. Again, a triangle. So half 5 pi minus 3 pi. And then the same thing, 3000 minus 800. But you need to see if this value is going down and up, you need to see it accordingly. Okay? All right. Once you do this thing, it's all in your favorite device. You crunch the number and the number will turn out to be 14100 pi Newton meter. Okay? And if you need to calculate T mean, which is total torque, which is area under the curve, divided by total revolution. So 14100 pi divided by 8 pi. So we get the value of 176, 2.5 nanometer. Oh, sorry, not nanometer, Newton meter. This is the T mean value. Once we get the T mean value, all we need to do is to find out the power of the motor, which is equal to T omega. But which torque? The mean torque. What is the omega value over here? Which is given over here as 250 RPM. So 1762.5 multiplied by, we need to convert the RPM into radians per second. 2 pi 250 over 60. And hopefully you'll get some answer, which is 46.143 kilowatt. So the part A completes here. Any question? So you can see, seems like the discussion was very complex, but the numericals are very easy because all we need is to make this composite diagram into smaller pieces and then find out the area under it. Yeah, that's a typo error. This is what I said. The last 1.5 revolution, the torque is constant. And you can see it, why it is a typo error, because it says 4 revolution. This can only possible, 4 revolution are only possible once you add these. Okay. Otherwise, if it is half revolution, you ended up with 3 revolution. All right. So we'll move to the part B. What is part B? Total fluctuation of this. So what is the formula of this fluctuation for the part B? The fluctuation, the formula was this: E equal to I omega square, which is equal to E m radius of gyration omega square. What is the E? Small e. Maximum fluctuation of the energy. Okay. What is that maximum fluctuation of the energy in graph? It is basically the amount of energy or torque above the mean torque. Okay. So we need to find the torque above the mean torque. So we'll draw the torque, revise this area under the curve thing again, and we will be able to find out the value of E. Then mass is given, K is given, omega is given, all we put it to it, and okay. So let me draw this thing. Is 172.5. What is this value? This is T mean value. Okay. So this is the T mean value. Now we need to find area under the curve of this. Let's say 4. We need to find out this 5, 6, and 7. Okay. Or we can name them as well so that we can easily identify them. Let's say we call this point J, G, H, and K. So to find the value of E, we need to find area above the mean, which is equal to area BJG plus area BCGH plus area CHK, or in other words, simply area 5, area 6, area 7. But now there is some problem. What is that problem? We know this thing here directly mentioned over here. But on this part, GJ or JG, we don't know the length of this. Similarly, for GH, yeah, this side is known, so no problem. But HK, we don't know this. So what we need to do? We need to apply a concept which is called similar triangle. Have you done this cosine, sine? They are the same ratios, nothing. Okay, the concept of similar triangle is very simple. Let's start with this. This angle, okay? So what is a cosine? P over or B over P? Okay. If I make another line over here, okay, and this one is a small h, and this one is a small b, and the angle is not changed. You get the same value of cosine because the ratio is changing. So you get, and if you forget this cosine, all the ratios are same. Any line over here, or even if you extend it, the same ratio, the ratio remains the same. We call it similar triangle. You can apply it on the other sides as well. Okay. Let's say this is A, B, C, D. Irrespective of cosine and sine, any two lines you divide it, the value will remain the same. For example, let's say you say BD or AB divided by AC is equal to BD divided by CD. The ratio will remain the same. This is called similar triangle. You know that? Yes or no? Okay, I think I have to give me this. So based on this, we need to find out the value of G, JG and HK. Let's start with the first one. Let's consider the triangle ABL and triangle JGB. Any two lines you take, any two lines, okay. Let's say we say BL divided by AL or AL divided by BL. AL divided by BL equals to AL divided by BL. So we say JG divided by BG. JG divided by BG. So what is the value of AL? Pi. What is the value of BL? 3000 minus 800 equal to JG. This is something we want to calculate. And what is the value of BG? 3000 minus 1762.5. So what is the value of JG? Can you calculate it? 1.767. Pi or just this value? What is the value we have in the solution? Oh my God, we have exactly the same solution. If you try to memorize it from the solution, which line to divide, which line, you'll get confused. Okay, so there's no need to memorize which line to divide. And inshallah, in the assessment, you won't get exactly the same figure. It can be the lower part here and then. So if you just, you need to develop the skills, and that similar triangle things, you already know what this thing. This is a very simple thing. All sine, cosine, everything comes from the same concept of. Okay, understandable? Let's calculate without even looking at the solution. Now this time, we'll talk about the triangle CMD and triangle CHK. Okay. If you divide this line, so we don't know the length of this line. So CD line or CK line doesn't make any sense to use. Okay. Let's do this thing. CM, this line divided by or MD divided by MD divided by CM equal to MD. So we'll put this one and this one as denominator. So we'll put the same ratios. All you need to do is if you use the base first and divide by the perpendicular, so follow the same. Or if you don't want to memorize what is base, what is perpendicular, just remember this line, same line, same line. Both will be above parts, both will be the lower. Okay, MD, HK. That's why this labeling is very important. If you don't write these labels, you get confused with the numbers. The last thing you need to do is to touch the calculator. First, you need to formulate the problem. Once you formulate the problem, then the calculator will inshallah give you the right value. If you don't, things can be different. This one will be CH. All right, just put the values. How much is MD? 5 pi minus 3 pi. How much is CM? 3000 minus 800 equals to How much is CHK? HK we need to find out. How much is CH? 3000 minus 1762.5. So what is the value of K? 3.53. Or what is the value in the solution? Oh my God, we cannot get better than this. Okay. So every time I say to the student, just remember, just learn this skill of this concept of similar triangle, which you have it already. You've done this geometry course, you've done this differential, integral course, they're all somehow related to the similar triangle. Okay, understandable? Can you remember it? If you remember this, how we did this value, then if the shape of this input data or the input data is changed, you will still able to do it very, very quickly. All right, all we need to do is to put the values over here. Now we say, what is the area 5? Area BG, this area 5. Because it's a triangle, so half base is, how much is the base? GJ 1.767. Okay, multiply by how much is the height? 3000 minus 1762.5. Am I right? Plus area 6 or BCGH is 3 pi minus pi multiplied by 3000 minus 1762.5. And the last triangle again, half base is HK. Value of HK is 3.534 multiplied by the height, which is 3000 minus 176 T mean. Okay, once you put all these numbers, you probably get some value. The value over here is 11055 Newton meter. And then you put it into the fluctuation, 11055 divided by, what is the form? M, which is 800. Radius of gyration is 0.5. Omega is, again, it's in RPM, so we need to convert it to pi n over 60. Don't forget this square. Once you put everything into square, you turn out to be 3.58% fluctuation will be observed for this task and this flywheel. Okay. If you want to reduce the fluctuation, what solution you proposed? Either go for the higher RPM, mass, but the RPM and radius of gyration are having a square effect rather than the mass. So better to increase the radius of gyration. How to increase the radius of gyration? Rather than wasting some more money and buying a more mass, what we need to do is geometrically change it. What does it mean? From the axis of rotation, make this mass more, to make a hollow near the rotation axis, make the mass more away from the rotation axis, and hopefully this fluctuation will reduce. Okay, assuming the other parameters remain the same. Okay.